So here we have the Rotax 750 installation, and we've already just installed the motor mount. We've painted it white using a paint, just a regular paint. In Canada, Tremclad. In the US, you call it Rust-Oleum. We use this for several reasons. We use either a flat white, sometimes a gloss white, depending on what the customer wishes. But we use this because it allows us down the road to see any type of cracks or any movement within the mount or the welds. If you use a powder coat, it's quite possible, especially a home powder coating, that you end up with the coating too thick, and it will hide any cracks that can develop. Also, you'll find that if it wears at times where the bolts do go through, it creates almost a sandpaper action and wears onto the bolts. So you can actually have a sloppy bolt and not know anything about it. So in this, we have the mount on, and we've also already installed a gas collator. Now, this is a little bit different than what you've received in the kit. What we've done is we've ordered in the Van's gas collator. It can also be gotten at Aircraft Spruce, but Van's Aircraft offered this at a fairly decent cost. And it has a pass-through into the Firewall, which we rather have that than what is in the kit. It's just one step up. You don't need to go there, but that's good. Then we also have a mechanical fuel or electric fuel pump. That is secured onto the Firewall. And because we're using a Dyna package which has a fuel flow calculator, also has a fuel pressure sender into it, we have on here a fuel rail. Now this is just a simple air manifold. You can get it at most tool stores. Princess Auto in Canada, Harbor Freight in the US do supply these. Or you can actually make one up yourself. It's just a fairly straightforward aluminum rail with a straight drill right through, and then 4 drills in the top. You don't need to have 4 holes in there. Just 2 will be fine for what you need. And as we see, we have the electric one that comes from the gas collator down here, comes into the electric pump, and then it's fastened directly to the manifold. Now on this manifold, we've used aluminum tube in through our bolts, and this is our standoff, so that we have the fuel rail at the exact same height as we do for the electric pump. We have the mechanical pump here. If we look at the gas collator, we have one fitting here that feeds up to the electric pump. On the other side there, we're going to have another fitting, and that'll feed up to the mechanical pump on the motor. And then from the mechanical pump on the motor, it will come back to the fuel rail in here. And then from the fuel rail, it'll come up. We'll have a pressure sender probably in here. And then from here, we'll attach our fuel flow calculator. And then from here, we feed to the engine. So, and you'll see that as we progress down the road. Right now, we're just putting on the motor mount and just getting some of that laid out. So with the large plates that we have on the 750 Rotax motor mount, you'll notice here that on your pre-drilled firewall, there's going to be one rivet up into here, and it's underneath the mount. That creates a bit of an issue, and it's located here as well as the one over on that side as well. So what we're going to need to do is the mount will have to come off, and we will drill out that rivet, and then we will chamfer it, and we'll flush that rivet in so that it'll be flush, fit into here, and then we can put the mount back on. So as you can see on this rivet, there's a normal rivet here. There's a normal rivet right there, which we use the concave head in order to create the dome effect on the rivet for strength. But up in here, we've taken this one, we've chamfered a bit, and same with over here. We've chamfered it, and it's sitting flush now. So when we put our mount on now, it'll sit over there and it won't interfere. It'll be fine. So we'll go back to putting our mount on and get that bolted in. And if you see, there's a couple of things different from the old 601 series, is that they have the upper support there, which haven't drilled that in yet, but we'll get to that in a bit. But in here, you'll see the main motor mount is right into here. So there it is there. There's also, probably it's going to be an AN4 6A. So Right now it calls for a 3A, but I think we're going to go up to a AN4 6A. Also installed the plate for the oil reservoir. So that's already been in, and that was actually squared to the channel up to here. And the measurement for that is 100 millimeters down from the top of the channel, bottom of the channel there, or the shelf. So we'll get the oil cooler installed. That's very simple. Just a couple of these. We'll put them in through the hole. It'll capture the oil reservoir, and then we can move on from there. Keep in mind that the top strap, you either leave it undone or leave it extremely loose right at the very end, and with a little bit of jigging, a little bit of joggling here, you can actually get the oil cooler oil reservoir right in. And there it is. Now it's pretty hard when you're holding a camera and doing this all with one hand, so I'll turn the camera off now and I'll go back and we'll just set this up just a bit higher, right about there. That's where, you know, fairly close to the shelf there. And we'll just strap that in. Fairly straightforward install. Yeah, you just put in the bracket into the back, and there it is there, and just attach the oil tank to it. Now, a couple of things to keep in mind is that we want to install the water bottle, so we have to make allowances for the room of that. So the one thing we do when we're installing the oil reservoir is we account for the reservoir for the overflow bottle. And that is going to mount in here, this area, and we're going to be putting a hole through here for the cap. So this will come out, it'll be mounted. We'll figure out where the hole is going to be, where it sits. We'll drill a hole through here to the shelf and mount it up. Now, cautious, this gets very hot in flight, so we want to ensure that we have a good amount of distance in between here. But we also want to ensure that we're not going to get in our way of our controls or the L angle that'll be up into here. So somewhere's around there, and then this will go in through here, lock in through the hole, and this will be riveted on in place, and that'll be all secure then. Here we're installing the throttle linkage mechanism, and you'll see that we've pretty much laid it out, and we're going to come in our standard, we're going to come in 4 rivets and use that one for the bottom of our block here. And we're on the other side, there are 2 rivets in for there. And we'll go into there, allow a little bit of play here, you know, just, you know, it's going to be snugged up fairly well, but not up tight where the weld will actually bind in here. You're going to leave a little bit of spacing in there, and that'll work out well. Also on the channel you put into here, make sure you give it a little bit of a slice. We put a little 45 in here, follow it off. That way you have clearance for your arm to go through. Okay. So here we are hatching on the throttle, and the alignment is very simple. Just by bringing the arm over, and you can get a straight alignment on that for your cable. This is all in place now. It's snug. It's not going to go. You have a little bit of play in there just to ensure that you still have nice, easy movement. And we'll put on this, and then we're going to put the doubler in behind it. Go ahead. Now we've already drilled this out and fitted it, and now we'll come over and do the other side, over onto here. It's a lot nicer when you install these motor mounts before you install the top or the windshield. Once the motor mount is, once all these are in, then you have to crawl up underneath. Plus the panel's in on this plane as well, so this makes it a little harder to get into. This is where it's a great advantage to have children. To send the children into those tight spots. Now when you're building this, you've brought in your cabin frame. And the cabin frame is centered right into the center here of the airframe, which there's a rivet line here. You can see this, and that's in the center as well. The plates that's on the cabin frame side line up with the edge of the second set of rivet lines, so on this side as well as on this side. That gives you your reference, and with that, we know that we can put the edge of the outside mount here on those rivet lines, and then measure the appropriate distance, and we'll be able to capture inside very easily. It's really nice when you have the skin off, and then you can put in a large C-clamp to clamp the two pieces together. It makes it a little bit easier to do. But if you didn't have the mount ahead of time, you can still do it afterwards. It just takes a bit longer. So that one's in. We'll drill this side out. We've already pre-drilled that out to a 1/8. We'll take it out to the appropriate size. We'll put the bolt in there, and then that should be all secured. Having a long drill bit like this does make the job quite a bit easier. Yeah, small advertisement for Mouse Milk. It's from Aircraft Spruce. It's called Mouse Milk Penetrating Oil. It's one of those products that we found very nice, cost effective. It's quite reasonable in the cost. It was $5 or something like that, but for doing a lot of this type of steel drilling in that, the Mouse Milk is just it's a great oil. The rule of thumb when working with AN hardware is typically it'd be nice to have no washers underneath the head. Simply because on an AN hardware, you'll see that the head has a machined washer built right into it. Alright, so we prefer not to use any washers under the head. Once the nut's on, we're allowed between 1 and 3 threads showing. We need to have one. It should be 1 full thread and no more than 3 full threads. So we can take that up with washers if we have to. And okay. So if we find that we have more than 3 threads showing, we're allowed to put, and we should have 1 under the nut, by the way. We're allowed to put 1 under the head and 2 under the nut. And that's the maximum that we should be. If you require more than that, then you should be switching out to a smaller bolt. If you don't have 1 thread showing, then you need to go to a larger bolt. There is no under recovery for that. Okay. And we'll come back in with a torque wrench on that, up to the appropriate torque. If you're ever looking for the torque specs, you don't find them in the builder's guide, then download yourself a copy of AC 4313B. And within that, on chapter 7, it'll have all the torque specs for every size of bolt and in what situation the bolt is in. So use that and have a really good torque wrench, and you'll be fine. Now we've set the torque wrench for the appropriate inch pounds, and we're just going to. Okay. So now that we've done all the bolts in the plane, when we get finished, and we'll come back with some nail polish, but we've done these 2 already, so we're just going to mark them. And we put a mark into them so that we know, we can see visually when we do a walk around if they've moved at all. It also helps us to keep in mind that we've done these things. So we want to use the front tray there as the level. That isn't going to affect it there? No, it won't make any difference back there. So we're going to let a little bit of air out of this tire so that we get this into level. And the airframe is out the same, so. Alright, so a quick way of just leveling the plane. We're going to be putting the Lord Berry mounts, these here, on here and here. The male version is the one in which all the weight sits onto. So this is the one that's going to be used in this situation in here. The female version, the top one, which will slide over, that's the same distance width as the bottom one, in which the mount sits onto. We can't just move this to here and get our holes, because once we lift it, that angle will change. What we can do, and we're going to use the mount to help us along here in order to just guide our drill and everything. Not the most scientific way, but I've always found really good, quick results with it. Okay, and we'll check the level of this. Now, as you see, the level doesn't fit there, so what we'll do is we'll put a block into here and mount the level to that. Found a piece here, which should help us out, just offset. Put our level up under there, and we just set that. I'll also check our center line as well, but right there looks like a good setting. Great, so let's pin that one. So here we have the motor fresh out of the box, Rotax 912S, the 100 horse version, and we've enlisted our hoist to lift this one. It can be done with two people. I rather not do that. It's best, if at all possible, to use something like an engine hoist, which we do have one over on the other side of the shop here, but it's got a motor on it too. So we've had to enlist our hoist for today. And we're going to take off the bottom brackets that came in the shipping container. So we look at those brackets there, and just take them off. The hardware, take that off, throw that all away, you're done with it. And we're going to install the two brackets that came in your Firewall forward kit. Okay, so it has to come to... We've already installed part of the mount. We still have a couple more things to do, but we've installed this plate as well, which we may have to remove to do a couple of small things later. But one thing we do have to keep in mind is, on the bottom of the motor, we have a banjo fitting for our oil. So there it is there. And there's actually two in the Rotax, one here and one up in the front. Now, this one here is for a push configuration for the oil drain. So we are going to use this one. Now, this one here is not going to be in that direction. And if you look in your manual, and you'll see in this video somewhere, that there is a bend radius that's allowable for the oil lines and even for the rad lines. We're going to observe this bend radius, so which means that we have to reposition the angle of this. Keep that in mind when you're installing this. If you can just loosen this bolt off just a touch to be able to reposition this and tighten it up later, sometimes that's a good thing. But we'll get to that in a bit. So when we look at the stock configuration of the way this motor has come, we'll see that we've got a 45-degree fitting here, or 30-degree I believe, and it's binding on the mounts there. So what we're going to have to do is we're going to have to take off the water pump jacket, heat it up a little bit, and just rotate that up a little bit so that we have clearance for the pipe along the mount. And we'll have to do the same, I believe, a little bit for the other side as well. And we've decided that we want to move the fitting on the motor as well, just a little bit. So we're going to have to heat this up, but we want to be, now the engine's going to see far more heat than what this would normally provide. We want to make sure our spark plug covers are out of the way. The spark plug, we're going to be very gentle in through here, especially with the tubes in here, so we have to be very cautious. Direct the heat just on where the fitting is, and we should be just fine with that. Okay. Now, as I turn that, I was looking at the angle and ensuring that the angle gives me the best run straight to the water jacket there, for the water pump. And we'll do the same on the other side now. So here we are on the other side. Just going to pull the spark plug covers off. We just want to move them out of the way. And we got to take the fitting off. Now the fitting's just a simple squeeze fitting. And we can just use a pair of pliers for that. Move it back. Now when you're working with these hoses, one thing you're going to find is that it's been on here for a little bit now and it's kind of locked itself on. If you can twist it by hand, great. Okay, so see how I got it to twist there? Once you have that twist, then pulling it off will be quite easy. All right, so we got this one freed out, and I'm going to turn this one just a touch. Once again, be a little cautious with the heat. We don't want to bake it. We don't want to harm anything. We just want to, all we're after is to soften the compound a touch. And this compound it's pretty good in its flexibility and what it allows. And we're heating it up more than what you would normally see. But once it's cooled down, it will reseal itself and it should be fine. Now once again, I'm not going to say in your case that it's 100% going to seal. Unfortunately, this is not going to be something you're going to know until you go to run the motor. And then you check for leaks during that time. And if you do have a leak in this, then you can try and remove it. And if you can remove this, once again, being a new engine, you've got a lot more flexibility. You should be able to remove these pipes, no problem, and retain the threads on them. Clean them all off. Clean off the threads on the inside of the head, and then put in the new compound and reattach them. But if in any way the threads don't look good, then definitely replace them. They're not that expensive, not in dealing with the whole motor, and this is just not a place you really want to play with a whole lot. We've got both sides moved, both sides of the water pump moved. Now we'll let everything cool down and we'll reinstall it and put our pipes on. Then we'll double check. Make sure that you have a nice clean flow, and we're going to end up having to, on the pipes, we're going to have to put some doubler around here, some rubbing material, because there will be a tight spot in here and we just want to protect these hoses. But we'll really reduce what the risk would have been if we had done nothing. Okay, so we've pulled the motor up and we're going to remove the water pump jacket because we need to move a couple of these flow angles a little bit, and we're going to just change the direction so they don't interfere with the bolts on here and then with the motor mount here. So what we have to do is we have to take this off. We're going to haul out, take this piece off as well. And we're going to heat it up a little bit, and we're going to turn it. Now we're also probably going to do a couple on the heads, and you'll see that in a minute. Keep in mind that you've been working with an airplane made in the USA. So all the hardware so far has been Imperial, which is what the US uses. Your Rotax motor is manufactured in Austria, and over there in Europe, the standard is metric. So you have all these Imperial tools, and you just found a new reason to tell your honey, significant other, that you need to buy some more tools. So a little metric set of Allen keys, and of course you'll need some metric sockets and stuff to work on the motor over the years. And buying tools is always a little treat for yourself. Some of these are a different length, so when you pull them out, make sure you lay them on your table in the pattern in which they come out, just to make it a little easier for yourself. I typically start at the top and work clockwise. Okay, and the very bottom one has a copper washer on it. It's a little softer, and that's where the water sits and pools down the bottom, so they want it to seal a little bit better. If you're very careful, once again, this is a new motor, which hasn't been run yet. So be very careful, the gasket will come off without any issue. Shouldn't be any tears or anything. And you should be able to find and reuse it. If your motor has been run, then order in a new gasket if you need to. So we've taken the water pump housing off and we've put in our vise. Now you should have some cloths or not cloths, some soft jaws in here in order to protect the aluminum. Don't squeeze it very hard. We don't need to put a lot of pressure on this. We're going to take off the outlet here. Now keep in mind that we have 3 positions in which we can move this. We're quite happy with the way it is right now, so we're just going to leave it in that position. We're just going to set that off to the side. But in here there's a rubber O-ring, so you can't heat up this unit without removing this O-ring. And we're going to need to heat it up on the fitting here in order to be able to turn these just a touch. And you'll see that in just a minute. These fittings that are into the water jacket are actually threaded fittings, and they're very thin aluminum, and they're held in here with a retaining compound by Loctite 648. I carry some in the shop just because I have it marked Rotax. The only time I use it is on this type of fitting. Because this is a brand new motor, this should work out fairly well. We shouldn't have too much problem by providing a little bit of heat around here. And we can't use a wrench on the outside or else we'll score the soft aluminum up. We come in with a bar and an extension bar, and we just give it a little bit of a turn, very gently. If it's a used motor, you might as well take them out, order in a new set, and some retaining compound as well. If you have any problem, don't force this too much. If you have any problem, you're unsure if you've actually moved it properly, don't play around. Take them out, get a new set, reinstall them, clean up the threads, reinstall them with the locking compound. This is a general process. It will work, but be prepared to be able to replace them if you need to. We're applying the heat just to the housing itself. We're not heating up the pipe. And of course, I forgot to clamp the vise down. Now your engine does come with some antifreeze into it, likely Evans, and you're going to see a bit of smoking from that stuff. Try to be in a ventilated area. Work this around pretty well. You just want to you just want to soften up. That went really well. So, and that's probably going to be enough. You may find this might be a trial and error thing for you. You may have to do it once or twice. If you can think of it ahead of time, you can always scribe some marks on here so you get a rough idea of how far you want to move it. All right. So now we've got the move the way we want. We're going to let this cool down naturally, and we'll come back and reinstall this and see if our distance is set properly so that our tubes clear a little better. On the water pump housing, now that we've determined that we're good with our location on these, we're just putting these in by our finger. Now, these actually come with lock washers, and that's right from the factory. If you're going to reinstall brand new lock washers, then by all means, go right ahead and you won't need any Loctite. But just because we're not installing some new lock washers, we're just going to use just a touch of the blue Loctite while reinstalling here. And that will, I mean, the lock washers are still in pretty good shape, but this will just reassure that we're going to be nice and firm in here. And always remember that the one with the copper washer is at the very bottom. It needs the extra washer, the extra soft washer, in order to retain a really good seal. We love Rotax motors. We're big fans of them, and quite a few of our customers are favoring these motors, which is good in my opinion. So it's nice to have an install video. These engines require probably a little more work to install than what the Jabiru ones do. Jabiru's, you know, a nice engine as well. But some of the benefits you get from the Rotax, being it's also a certified motor, and it's a very, very light motor with a great amount of torque and the capability of swinging a large prop. Having all those capabilities within this does make this motor a real performer. So we have a few extra things to do with it that you wouldn't normally have, but some of these are also good features. Having the liquid cooling eliminates the shock cooling issue on descent. So, you know, it does have benefits. The extra work is worth it. No, I'm not going to put the O-ring back in just yet. Okay, we're going to leave this off for a bit, and because I can easily access it through here. There's lots of room in the back here to be able to move stuff in and out. So, okay, so we've just reinstalled the water pump housing, and just finger tight. So what we want to do now is we really want to have a quick look at how our pipes are going to lay. So we reinstall, look at that. Okay, we see that our angle is in a little better, and it looks like it's going to clear a whole lot nicer. So with it sitting like that, we'll now reinstall everything. We're going to put a little bit of blue Loctite on these bolts in the back, just a little bit, and see how it all really lays out when it's done. Right, so one of the troublesome parts of installing the Rotax motor is to ensure that you have it as level and as center line and straight as possible on the mount fixtures. So we have the steel mounts attached to the motor, and now we're attaching them to the aluminum mounts, which are part of the bed and held by the lowered mounts. We've centered the motor, we've checked all the angles, and we're really happy with where it's sitting right now. So what we've done here, and guys, there's many different ways of doing this. This is just one particular method I use. I've used this in the past several times with great success, but I've done other ways as well. If you have a mill and you're capable of working to a very high tolerance, then of course you can just measure it all out and drill your holes in your mill. That's not always the case with most people. Typically we're working in garages, in our basements, and even in hangars where high-end tools aren't always available and precision tools aren't always available. So it's best to try and do this in another method that would allow us to use just simple tools. A drill press, I consider a simple tool. You can pick one up cheaply for $50, or even a better quality for around $200. So what we've done is we've centered the motor, we've checked everything out, we're happy with the way the motor is sitting, and we've come in with clamps, and we've clamped all 4 locations where we need to draw bolts. Now we're going to remove the motor. What we're going to do is we're going to disconnect the bolts that are attaching the steel mounts to the motor. So these ones up into here. We're going to remove the motor, which leaves us with our plates still in place. And everything is safety wired. And what we did is on these connections here where they attach into the motor, and on all 4 corners, you can see we drilled a hole in the metal plate, and then we just ran the safety wire through the bolt attaching, and that's done on all 4 spots. All the bolts are to the proper tension, proper torque, sorry, and they've been safety pinned, cotter pinned, and we're all set to move on from there. Okay, we've also worked on our fuel system a little bit. So this is pretty much the completed fuel system. The Rotax motor is now coming with the, at least in this Canadian version, it's come with its fuel lines already attached, which was in the past not so. We'd have to make up our own fuel lines. They're all heat shrouded, heat shielded, and very nice. So we came into our system, we looked at our system again, instead of going with a parallel system like we would normally do in this setup, we've come in with just a series system. So we've come out of the gas collator now, we fire sleeved the 3/8 line up to the faucet fuel pump, then we've connected from there into our fuel rail, and with fuel pressure, and we also have our usage block, and then we followed our line down. We've come to our manual pump, which then goes to the T intersection, and this section here is all done by Rotax right from the factory. We have 2 banjo fittings on the bottom here that feed out to each carb. So we're in pretty good shape here, and now we're into the radiator and the oil cooler. So if we look at that, that's these parts here. And the radiator comes with 4 isolators for vibration damping, and they hook right into the side of the radiator here. 2 brackets, which have a bit of a turn on them. They'll attach to the redrive. And then the bracket we've already installed on the motor mount. So that'll be there for the radiator. The oil cooler, the bracket's already installed, and we just have to fit that in. So one of the first things we're going to do is we're going to take our radiator and we're going to install our isolation dampers on. And you'll notice the radiator has a cardboard cover over the fins. I'm actually going to leave that on now, almost right up to when we do our first flight. So, during the, just before we give our final checkout, we're going to leave that on there, just to protect the fins throughout the rest of the build here. This just goes right in. And we've got a couple of lock washers and some bolts, and some nuts. I'll just put those on figure tight for now. Insert the top ones here. Now we look a little closer. What we're after, we look here, we see this threaded insert here on the side of the redrive. This is what we're going to use for our bracket. So we're going to actually pick up, we're going to install, supply bolts with the kit, and install these on top. So in the hardware kit you receive, we're going to be installing the M10, which is a metric bolt by 1.5 by 20 thread, and of course the washers to go with it. So we're after these two here. And we're going to use these to install up in this side and this side. So we'll get that in there. And we have our two brackets here. Okay, they'll go on like this. With the flange towards the outside on both sides. And then we'll install our washers on here, and our nuts on here as well. And I'm just going to leave these figure tight at the moment, because I'm still going to be playing with a few things in here to get things sorted out. Still pretty good access in here to your oil filter. And we've got just a pretty tight up against the oil pump housing, but there's lots of clearance. It's a good mount, and even with a little bit of vibration here that you may endure through the engine, it's still not going to touch the oil pump cover. So we're going to be installing this using our 4 supplied nuts, and they'll go in there and they'll trap in on the bracket we've already installed underneath. So we'll lower the camera, get a shot into there as that's going in. So here we are underneath the plane, and keep in mind that we've already loosened off the bolt up here for the banjo fitting for the oil. The reason why we did that is we needed a 22mm socket on here. And if you try to do that with a wrench afterwards to loosen it off, then it's just too tight. You're going to end up rounding the head of the bolt. So best to crack it now, get that done, leave it, just snugged up so it's not leaking oil, but you need to be able to move that and rotate it so you can fit your lines properly later. Oil cooler, we've already installed 2 of the nuts on here. Very simply, goes up into place. Well, we thought it'd be simple, but we'll just come in here. We'll relieve these holes just a touch, just so we can get in there a little better. we're just going to leave that a little loose for now. We still need to put our fittings into here and figure out our line routing, and that'll be in a bit. Okay, so that's in, that's where it's going to go. We have the radiator up here, and that's looking good. So with the radiator in place and the oil cooler in place, now it's time to just dry fit the muffler. And what we're after here is we're just going to set the muffler into place, get all the pipes in, so then we can start figuring out where the lines are going to go and how they're going to traverse through the engine and everything. So we'll get that in place, and from there we'll get that in place, and from there we'll figure out where we have to put in some of the other stuff. These fittings, they come with the engine. They're just to keep the engine dry inside, keep it sealed. These are of no use to you anymore. These are definitely of use to us. You definitely want to keep your copper fittings here. With this being a new motor, all our exhaust ports are nice and clean, and we've got the nice chamfer into here, which is factory fresh. If this is a used motor that you've got for yourself, ensure that these are still nice and factory fresh and well chamfered. If not, they can be reground. There is a tool that you can get from Rotax that can reground these, and then you can install an insert into here, which will give you the proper degrees on the face here. So once again, if you're going to install a new exhaust system, make sure that this is in good shape. Inner fittings that come from and with your Firewall forward kit, they should be marked on here of what they are. So if we look at this one here, it says pilot front side, and it's very nice they're doing the pilot and the passenger instead of the right and left. Sometimes you can get a little confused, but this way it's a little bit easier. We'll throw in our copper bolts again, and we're not going to put them all the way on at all. That's one of the very last things we do is engage them. Up to this point in time, it's all just hand tension. Also on this one, you may have to pull the muffler out a touch, or the exhaust pipe out a touch, just to get this one started. Once again, just hand tight, that's all we're after. This is the fitting process, and you know, it's pretty much going to be the same for most of us. There will be little differences here and there. Okay. Now here's the back ones. And once again, we have this one here marked as passenger back and pilot back. Now this mount is it's a little bit different than the last one I've done, last Rotax installation on the 750. They've added a cross tube down in the back here to make it a little more diagonally stiffer. And here's the muffler. Okay, quite an exhaust tube onto it. Quite large. All right, and we'll get to install this. Okay, so we already have our fittings in place, and we're going to mount the muffler. Now, in the previous version that I had done on this, we had the muffler actually right in behind the oil cooler. In this new version, the muffler actually sits right in the back here. Now, it is a bit of a Rubik's Cube, a bit of a trick to get into. It's very nice. It sits, you know, in a lot of open area. But once again, it takes a bit of a challenge to get in. We went in, came up like this, gave it a bit of a twist into here. There we go. And we need to come up through the top here just to bring in this piece on this side. There we go. And then it can come back this way. And this piece has to go on the outside over there. And it slides up into here. And then the fittings go into here. And we'll get the springs on this. Now once again, everything is still loose, so it allows us to play quite a bit with this. I'll just put a couple into here. And it works very well. Typically I'd use something like needle nose pliers and just pull up onto it. And they've been known to slip, and of course you get the pliers in a place where you don't want to. That's a nice little tool. I like that. So there it is. We just wanted to dry fit this. We're going to tighten, have a look at how this is sitting. And it's looking pretty good actually. This is nice. This is the new design to fit in behind here. Take up a lot of space that we have. We can get our cabin heat into here pretty quick. And I'm pretty happy. But rewind it, watch this, how it goes in again, how it snakes through, and it should be easy for you to do. Alright, so now we're into the fittings of the plane, and you know, in running our oil lines and our all the other lines as well. We'll just move this a touch. In your motor, you would have gotten the two fittings here, which come from the oil cooler. Or on top of your oil reservoir, there's a couple of markings, what you marked in and out. These are of utmost importance, and you're going to see here, just in a minute, you're going to see a routing diagram and understand better as to why this is so important on the oil reservoir. Inside the reservoir, there is the defrothing cage and everything else. Once again, you're going to see that shortly. We're going to have a little demonstration on how the system's routed, show the diagram, and how to run your lines through there and the dimensions you're allowed to use for bends and everything. So watch that and then come back and we'll have a look at this, at how we've routed it in here. And this is important, you know, write this down as you see the diagram, write it down so you have it on you when you come out to the plane. If you do make this backwards, then on your initial startup of your engine, it'll have an expected life expectancy of about 10 minutes. We need to get this right off the bat. All right?
Because the engine does not have a sump or reservoir to store oil, as with an automotive engine, an oil tank is required for this purpose. Oil leaves the center tube from the very bottom of the tank. It flows into the oil cooler. From the oil cooler, it is sucked into the oil pump, which is self-priming, and pushed into the oil filter, and then into the oil galleys of the engine. Oil exits the engine out of the bottom banjo fitting, the bottom of the crankcase. It's the engine's blow-down pressure from the pistons that pushes the oil out of the engine and back into the oil tank. Between the engine and the tank, this is an oil foam mixture of 50% oil and air. This oil foam mixture is discharged into the side of the oil tank where the internal screen removes the bubbles and deposits the oil at the bottom. If the connections to the tank are accidentally reversed, permanent engine seizure from oil starvation will result. Pure oil can only be obtained from the connection that uses the tube going down to the bottom of the tank, not the other way around. One of the most common reasons for engine failures, believe it or not, is ignoring the minimum bend radius for oil hoses, making the bends too tight and constricting the flow of oil. The minimum bending radius is specified at 2.75 inches or 5.5 inches in diameter. Always route the oil hoses in a way to exceed this minimum. This would be a great opportunity to take our oil tank apart and look inside to fully appreciate how it works and to understand why it has to be hooked up properly. Did you know that if you hook the hoses to this tank backwards, you will destroy your engine in short order, and you will be added to a growing list of builders that have regrettably made this mistake? There is nothing more than a screen inside. That's all that's inside there. Now, want to note the top, and to notice that the port marked in, this is for oil flowing into the tank that's coming from the bottom of the engine. And remember, that's 50% air and oil, a foamy mixture. Let's take a look at what this connection does. And if you notice, it doesn't do anything but deposit the foam right to the edge. And the reason it's going to do that is it's going to fall onto the screen and break up the oil mess as it falls to the bottom. If we look at the oil output, this is marked out here, the oil output gets the oil all the way from the bottom of the tank, where there's a pool of oil after the foam has been broken down into just the oil. So the output of the tank is what feeds into the oil cooler and then into the engine. The into the tank, after it comes from the bottom of the engine with all that foamy mess, simply falls down the side of the tank and through that screen where it collects down at the bottom. So very important not to switch the ins and the outs because they perform entirely different operations.
So we're going to work on the radiator system at the moment, and we're going to do some of the plumbing for the rad hoses and all that. Out of your rad, we have the 90-degree fitting. Now this 90-degree fitting also has an angle onto here as well, so you can see the angle. And that's going to be installed in this orientation so that we have the pipe, as it goes in, it actually turns away from the exhaust system. And we're going to put in a small piece in here between the two, and that'll get our pipe turned away, and then we'll run from here back to the water pump. Now, typically in these systems, you'll have one of these types of clamps, and as you can see it right in here. So you have one of those. Now, oftentimes you'll find these will leak. When we put them on, you put it on like this, and you'll have a weak spot just underneath where the mechanism is on the pipe. So we oftentimes will have to take a second one, which had dropped in here a second ago. We'll have to take a second one if it does leak on us. And we have to install it 90 degrees or 180 degrees to the first one, so that we have a clamping force back here and one back here on the pipe. Now, that'll work just fine then. It'll cure all your weeping issues and be a good process. The owner of this aircraft wants to go a different route though. So if we look, and I'll just bring over the connectors. Here's the one that we're using. okay? And that's with your kit. But these are the ones the owners wish to go with, okay? So this is a little more robust. We have a spring load up here to take up tension and expansion. Also, there is a metal sleeve on the inside to cover all the serrations and provides far more strength and a better seal all the way around the hose. Now, we can get these at Napa Auto Parts. They're not cheap. I believe these were $9 each in Canada. But we can go to Napa Auto Parts and we can order that part number. So you'll see us not use these in the installation. We're going to switch everything over to these. And we need 5 of them in this installation. So we'll install these 5 and continue. First thing we're going to do is we're going to install the short stubby hose. Now on this one here, just put it in. There's quite a flange here. Just put it on an angle, twirl it around, and you can get it in there. Takes a little bit of force, a little bit of work, but it will go in. Just check inside, make sure you're not chewing up the inside when you're doing this. Okay, so if we look close here, we see that our rubber is in fact creating, if you can see this, it's actually touching the muffler here, the exhaust system. So we're going to try and shorten this up a bit, give ourselves some free room in here. There's lots of aluminum tube and we have lots in there, so if we cut this down, the aluminum tube can be closer to the exhaust system and we should be fine. So we'll just tighten that up a bit and get that installed. Adjusting these, you can actually see the cowl move out and showing that the spring is engaging and give us an amount of play for expansion and contraction. Now this is a nice little connection. And we've got now the aluminum tube here close to this, and that's going to provide us enough clearance with that we can continue on. Install the long tube now, and we're going to come from the back of the motor, and we need to bring that up. Now, a couple of things we need to keep clear on here is underneath here we have the connectors for the water lines that are part of the motor here. And these connectors are just spring connectors. They're very light connector, but we need to rotate them. They have to be rotated out of the way so that they don't interfere with this tube that we're putting in. So I've already rotated these up and they're clear. The only one I'm going to probably have to move a bit more is this front one, but that should be fine. I left this just a little bit long because we're going to try and tuck it into here and bring it in around and nice and smooth. And that creates a nice tight seal into there. Right, and it's sitting just above the flange of the pipe. So the flange is just in behind the clamp, and it's a good seal. We need to look at how we're going to rev the hose. Now we still haven't attached our outlet on yet, but still want to just check this. Okay, so this in here, this connector in here is definitely creating some jamming issues. Well, not jamming issues, but it's creating some interference. We've got some metal points out here that the pipe could reverberate against, which we really want to avoid. And we want to keep this in as best we can away from the exhaust system. So we're going to rotate this and then just bring this around. And we're going to have a bit of a rub here, but this spot we're going to have to put in some doubler here. Okay, so sorry about some of the noise you're hearing. We have a helicopter school close to the hangar here, and it's a very nice day, so we actually had the door opened today. Now, nice in Canada is it's, I think, 52 degrees, and we're almost calling that a heat wave. So, the pipe's a little bit long. We're going to trim that off. It's time to reinstall the outlet. I'll just get this out of the way for now. And we'll need to put in the O-ring again. Now, watch the O-ring. Sure that it sits in there and doesn't move on you. It's pretty good in there. And just, and now we need to have a quick look at how we're going to install this. Okay, it comes from the factory, at least this one did, with using the 2 outside holes. And we're going to now install this and have a look if we need to change that location. We have 3 choices, so so the original location looks like it's going to be the best choice for us in this situation. So we'll go ahead, attach that. Now if you want, you can go back, you can install this before you start doing your fitting. Once again, this is there's some new parts in this kit from the first one I've done on the 750. So a couple of things are being done a little bit differently, and we're fitting everything as we go with this video. So that's why you probably see a little bit more of the process than just a, you know, do this, do this. Now while you can still watch it, always keep an eye on that O-ring. Make sure it doesn't slip out on you until you get it finger tight. Now we can no longer get the T-handle into here, so we're going to come in, socket, for those of you who have never seen this before, this is something that if you're working on your plane you may wish to get. It's a flex shaft for your ratchet, so it allows us to bend it around, go around parts to get into. And it's really one of those tools that are very, very handy to have. Don't forget to remove the plug. Standard, you wouldn't think you'd have to say anything about that, but there has been an instance where someone has left the plug in. So be sure that you have taken and removed it. Now we're just going to line up our hose here, figure out our play. I think there's been one of those clamps yet I haven't dropped. And there. So there's the rad hose from the water pump out. And if we look here a little bit closer on the side, we can see that it's got some nice clearance. We're gonna wrap this one a bit, stand it up, and we're gonna have it tied in quite nicely into this area. One thing to keep an eye on is feel the hose. If you feel any kinks into it, then you may have to shorten it or reposition it a little bit. That feels good there. So I think we're all set with that spot there. And we'll do some of that tie up near the end. We'll come back. We just want to be sure all our pipes are in line right now. We're roughing everything in. And then we'll come back and we'll set in all our ties and our standoffs as we needed. So now we have this side. We're going to take care of from the radiator up to the collector. And we're just going to bring it in here, just rough it for now. You know, put a rough connector in. and get a rough idea of how we're going to route this. We've done routing in the past where we've just followed the mount, come up and around. And yeah, not a bad. I mean, we can tie into quite a few spots. We're good away from the exhaust system. But we'll also look at, let's see if we can go through here as well. So there are two ways, acceptable ways that we can run this hose. And the one way is right here. And we come up underneath the heads. We're attached on there. There's no nice straight in through here. We can attach up in here underneath the starter with a standoff. And attach in on the mount here. And we can come in. And this way there's no kinking of the lines. And essentially it ends right there. So we're not using any of this weight. The other method you could do, which will work out just fine. So we can also come out. We'll stay up under the heads just to keep away from the heat source. Come out, we can tie into here and come up, wrap up around here, and then we can gradually come back into this area, back into here. That'll do a few things. It allows us to keep it nice and clean, keep us up. Connection into here will do well, and nice gradual into the water collector and the glycol collector. But we've added a lot of extra weight, and we've added all this extra hose, this extra water, everything else. Both are routing nice. Both are going to keep within our allowable bend radius. It's up to really you to choose this one. I've shown you both ways to go. Whichever one you want to go with is fine. I don't see a problem with either way. We've chosen to go through the inside underneath the starter and get in through that area. It keeps us away from all the heat sources. We're good that way. But the big advantage is we're essentially not going to use this much of the pipe. Not much of the pipe, that much of the water. Doesn't look like much, but weight and balance, we got to keep our eye on all that. So this is a significant savings for us. So we'll refit that the other way. Set up to the distance, chop it, and just clamp it in, and then we'll come back again later and we'll do our standoffs and all our tie-offs. So we're good there. Stuff to come in here, move these around in here. And get on that right now. In the kit, you receive these fittings, which are threaded on one side and a barb fitting on the other for your oil lines. And they would go up into here. Now they are a tapered thread on there, and we do have a straight thread on this. There's nothing wrong with them. They actually provide quite a free flow of oil, and there's a nice big opening on them. But we've opted for the banjo fittings on this plane. Okay, so we've installed banjo fittings. Now, if you go with these, which are part of your kit, and they work just fine, they're on got another Rotax I've done and a couple others, you may find that they stop at a certain angle, and you tend to have to install some type of a thread lock or some type of a compound in order to keep them at some angle. Another thing to do is install a washer underneath here, so that you have a washer between the threads and the shoulder here, so that the part will stop exactly where you want it. That takes a little bit of fitting, but it's quite doable. Instead, we went with the banjo fittings. You can get them at a local hardware or local car automotive store, and they're pretty good too. And with the bolts, which are a straight thread, we threaded into the oil cooler a lot better. So we've done that. Now on this one, we've routed it. We've gone out, and we're going to tie into the side here. We'll put a standoff into here. So we've routed out of the oil cooler, and we come straight out. Now, we're coming out of here, and we're going to tie into here, and we're going to stay away from our muffler. We're going to come down along the engine mount, and we're going to come up, and we're going to tie into our oil reservoir up here. So we have a nice, graceful line. We're in nowhere near any of the bends, and we have a good flow through the whole system. So we'll get that installed, and then we'll do the other side. Alright, so now we look at our oil run line, and there it is from the oil reservoir. And we're going to run that down along the edge of the motor mount. And of course we have standoffs in here as well, as you can see. Okay, that way we have no rubbing. We also use the motor mount bolt there as a standoff as well. So our tube is centered right in between the two motor mount bars. And that goes into our fitting down there, our banjo fitting down inside. So as we look at that, we come over and we look at the routing for the other one. And here we are, we can see the routing for the oil pump. So that's connected, comes down. Now we will be installing a standoff, which you see right there. That holds it. And then it connects into the other banjo fitting down into here. Now we've pulled off, and keep in mind guys that your engine does come with some oil into it. That's the pickling oil. And it should be a straight mineral oil if I remember right. And we're attaching the banjo fitting for there, and that's going on the tube, and then we'll show you the routing of that in just a second. And as you can see, we're wiring it up at the same time. So all the wires are still quite loose. They'll all be captured, and you'll see that near the end, and they'll be all cleaned up. We just wired in our fuel block, our fuel flow calculator. Our fuel pressure is already wired in. So in here you'll see that we now have the other oil line installed, and we've come out of the oil reservoir, we've followed it down, and we've actually come in with the other pipe as well. We've gone underneath, we put in a doubler here for any vibration. And we've come in underneath into that. So that's how we've routed this. Now we tried running this tube several different ways, but in every way we tried, we ended up with some type of a bend radius violation. Coming through this way is a nice clean install and nice graceful lines with very little, actually no tight turns whatsoever in them. We're going to have a quick look right now at the oil pressure sender. This is a new motor from Rotax, and a very strong possibility the motor you've ordered will have this new type of oil sender. And it comes already pre-wired. It comes with quite an extensive wire here. The older version was something similar to this, and what you just ran your two lines to it and you picked up from this. So, and that was always easy. This new one's a little bit different. This one does require a 5-volt exciter. Well, I check again on your voltage and check your manual for that. I'm going by memory, so it's either a 5 or a 12 volt, which it requires a voltage inserted into it, and then the readout line going back to a glass type of panel. These ones used to be read by VDO gauges. Very simple, very easy to do. But if you have this, the VDO gauge is no longer any good. You'd have to go with some type of a glass panel which can provide power in. So keep that in mind when you see this. If you need to, you can order up one of these and just switch it out if you have the older style. But mostly everybody now is going with some type of a glass arrangement and a glass panel. Dynan, Grand Rapids, these sort of things. Personal opinion, the old steam gauges were fine 10 years ago and even up to 5 years ago, but they're not as accurate, they're not as dependable as what today's electronic versions are. And once again, that is a personal opinion, and it is one I hold. And I find that the more information I can have about the engine, the faster I can have information about the engine, the safer it is. So in that, we have some new hardware going into here, and we'll move on and start hooking up things in here. Okay, so we've got our oil lines all hooked up, and we're trying to bring some oil through the system. We want to do that long before we ever try starting it. So we've unhooked the line that goes to the oil cooler, and we're using the last port that we're going to dump and push through the engine. We've removed all 4 spark plugs, or else I wouldn't be turning the motor over this easily. You can do this by yourself, but it is a whole lot easier when you have a friend here to help. Alright, so now it's all poured through. We're going to rehook up the hoses and we'll let it sit for a while. Probably, well, we're going to let it sit overnight this time. And tomorrow morning we'll come in and we'll put the plugs back in. And then we'll rotate again with the plugs in. And what we're looking for is we're looking to see the burp in the oil reservoir. So we should get that gurgle, and then we know our oil is all the way through. Okay, so this for the throttle cable, it's going to be coming through the firewall. What we want to do is we want to install a B-nut on here so we have nice free movement as it rotates around. This way there's no binding. But we don't have a B-nut long enough, so we're just compressing this tube a little bit. As you can see, we've already started, so we've got a compression. Nothing sharp, or else we'll end up with a slice on there. We don't want that. Just enough to get the B-nut into there. We'll drill the hole again to make sure we have the proper size, and then that'll work just fine. When you go to install the choke on here, you get these in your kit, little connectors. Right? You're going to find, and you want to make sure that your shielding seats all the way into here. And you're going to find that it's very tight. From the factory, there's paint inside. So what you need to do is come in with a drill bit, put it in a vise, and just give it a little ream, just to clean out some of the paint that's already in there. And once you have that, then ensure that you thread these all the way up. So it's seated all the way in there. They're still pretty tight. There, we have them. Okay, so these 2 connectors are on, and we're going to now go in and install them into there, and you'll see how we did that. So there's a picture of our choke setup. We've come in with our 2 fittings over here, and we built ourselves a little bar. And we have the 1 fitting over there.
That works excellent.
Okay. As we pull, draws them evenly. And there's the cables running to the carburetors. And we've set in the carbs. Now in your kit you get 3 barrels for the lock for the wire to lock the wire in. We have 1 here, 1 on the other side of the other carb, and of course the 1 that we used in the middle here for our choke cable. Alright, so we have the scat tube, and as we can see, when we try to put it on the housing, the wire will oftentimes get in the way. If you can get it on, great. The wire on there would be really nice, but in this particular case, it's just not going to go on. So we're going to take up a set of needle nose pliers, and we're just going to pull the wire out a little bit. You know, just enough to give us the ability to slide the scat tube over top. And we reach inside the scat tube with the diagonal pliers, and we just snip off the wire where it is no longer connected. And then now we should be able to put the tube onto the heat box in this case. There it is. It's on the heat box. Now we'll put a clamp on that, and we'll figure the line up for the other side, and we'll connect it to the heat unit, the muffler shroud. Alright, so there's the scat tube installed. Now we're starting on with the wiring. And we're wiring up the motor now, and the brown line that you see is from the Dynon exhaust gas probe, and it's actually marked on there somewhere. Should be a little yellow tab. There it is there. Now on the Dynon, for the Rotax, you're going to be doing the 2 rear cylinders. Not opposing, not diagonal cylinders, but the 2 rears. And on there, the yellow tag will say exhaust gas temperature either left or right. So we've already got the right installed, and we're just doing the left now. And we're going to clean up, we roughly route our wires, and then we do a cleanup of them at the very end, which we wrap everything. In running our wires through the Firewall, we've installed this Firewall pass-through kit from Safe Air 1. And this is one of the kits that we tend to use every once in a while. Alright, so right now we've already dropped our cable inside for our power panel and for our instruments and all that. And what we're going to do is we're going to create our master solenoid. Plus with the Dynon D180 we have an amp shunt in here. So we're going to come in, and we've already drilled our 4 holes in the Firewall so that we know we're not interfering with anything. And the master solenoid is going to be installed in here with the amp shunt on the other side of the Firewall. Well, both of them will be on the other side of the Firewall, and they'll both be installed like this. So we know that our gap is like this, and because it's rather difficult to reach up into the top of the Firewall, we really don't want to get in there and start playing with all these connections. So what we're going to do is we're going to make up our quick connect from here to here, and we've already made our connectors for the one going in through the Firewall, and we'll just wire these up and then place them in, and then we can hook up our power panel into here. Our Dynon will hook into these 2 here, that one and that one, and then we'll also have our master switch attached onto here. So we're going to get into that. We're not going to show you how to do the wire. We've already showed you how to crimp. So it's a matter of, at this point in time, we'll just do this, and we'll come back and we'll run the camera and just review how it's all in place. All right. We're going to install the start solenoid at this point. And we pick this position right here, which keeps us clear of all our cables, and it allows us a nice, even, clean wire up to here. From here, we'll go back through the hole to the amp meter shunt, and then over to our power panel from there. And then we'll come from here and we'll head off to our starter solenoid, to our starter. From time to time, it's actually necessary to get in under the panel and do some wiring. We try to do as much as possible beforehand, but you forget the odd thing, or the odd thing can't be placed in time. In this particular instance, we're putting in the amp shunt for the Dynon D180, and we're putting in our master solenoid. We've already pre-drilled, did most of the work outside, tried to do as much wiring outside as possible, but we're in the upper end of the Firewall, so typically you're looking at that point of crawling into the plane and, you know, laying on the seat, laying backwards. Not always the safest place to be. If you're ever going to do something like that, at least have someone around, because you can actually get to a point where you get trapped in there. Working in there for a period of time, you get fatigued, and then trying to get out can be really troublesome. What works better is the scaffolding. So as you see the scaffolding I'm sitting on here, this allows me not to have to crawl inside the plane. I got all my body weight out here sitting on a scaffold, and I can just go in, my shoulders rest on the edge of the seat, and I can reach everything inside there and do almost anything I ever need to. So, you know, that which I can't reach by sitting on a seat and just reaching in, like installing the shunt, I can just put the scaffolding up here and just lay down and get right in under the panel. So at least it shows how you can get in here and get things placed and get these nuts on and all that. And there's where we have the shunt over here. Shunt's over here, and we're putting in our master solenoid. So,
Oops, wrong side, too much wire. I'll go to the other.
so we're hooking up the Dynon CHTs now onto the Rotax motor. The Rotax motor CHTs require a 5-volt exciter cycle input. And at present, once again, read your manual because things changed since the time this was videotaped. At present, we're using the red and white wire. That's the 5-volt exciter circuit. And in that, we're going to have to solder in 2 resistors that come in with the kit. Those 2 will get soldered into here, and then they'll feed off from there into the Dynon wiring to the CHTs, and we'll have to reconnect the ones back into the panel. So just both resistors get soldered to the white and red, and the purple and blue and purple and yellow get soldered to 1 resistor each. Ensure that you use heat shrink on your circuits. So we have a little piece of heat shrink here that we're going to use on the individual connections, the individual resistor. Then we're going to cover the whole thing with a bigger one so that it's a nice sealed up circuit. If you can think ahead of time and do this inside the cabin, that's fine. But we're out here and we're into this plastic cover tube here, so we're in pretty good shape with this too. Okay, so now we're hooking up the rectifier, and the 2 yellow wires that come out of the alternator are connected into here, and they both go into the area marked G. Okay, polarity is not important here, and you'll see in a minute John will show you how to assemble these and do the wiring and all that. Plus, in the manual it says to use 14 gauge wire, so we are using that in here.
Let's take a quick look at how to attach and remove the terminals from this black plug. It is simple once you understand the technique. Closely examine the connectors that are already installed on the engine's generator leads. You will notice that each terminal has a small tab that protrudes upward from its body. This is a locking tab that will secure the terminal in the black plug. This tab will need to be depressed when removing the connector from the plug. A small screwdriver or other appropriate tool will be used to push this tab down when removing. Inserting the connector into the plug is as simple as pushing it all the way in as far as possible where it will lock in place. Removing the connector requires depressing the tab through the front of the plug and gently pulling the wire from the back. With a little practice and a tool similar in size to an eyeglasses screwdriver, this is a simple operation.
We use just a crimp connector here, okay? And what we've done is we've run 2 wires in here, 1 loops back, and then these 2 here into the yellow crimper. We've also installed another wire here for the capacitor. Now, once again, if your battery is continuously in the circuit, whereas this line here strictly runs right to the battery, then you don't need to have a capacitor in the circuit. We are going to be doing an on-off switch for the alternator, so we can shut it out of the circuit. So we actually do have to install a capacitor. So just simple crimp connections. A little bit of heat shrink on there again. A heat gun is preferred when doing heat shrink. But at this point in time we don't have one available. So we're just going to use our little butane torch. We have a butane torch here that we use to solder as well, in case we're not anywhere near electricity. And then we'll connect them in here. Now, because they are all connected to one line, you know, polarity here, or which one is which, isn't all that important. So we do have the other circuits here, and the one for the lamp, we're not going to be using this. We do have a dyno installed on this aircraft, so with that installed, that gives us more than enough information that we don't need to use the lamp. If you're going to use the lamp, very easy, just hook in the wire, run it back. Typically we use an LED if we don't have the dyno, and then just bring it out to the circuit again. When you're installing the Bullyhawk soft start module, which we have on this particular motor, what you end up doing here is you choose which mag you wish to use, the upper or the lower electronic module. We've used the upper one, it was just easier for us, a lot less travel in the wires. So you unhook the connector out of this one here, and you plug it into this one, which comes with the Bullyhawk. And then the soft start module, you install that into this connector. And then you ground the wire, and we've actually used, we used the front one here to ground the wire from the soft start module. We're also on our ignition wires, the red and green ignition wires that we've installed here and here. Now, once again, these are upper and lower ignition units, but we still refer to them as mags, and we still refer to them as left and right. So when I run the wires, I run the color coding wire, so right mag, left mag, and I use shielded wiring on them, and I come out of here with the shielded wire and I put that into this connector here, and we just connect that down where the ignition module is. This will be safety wired or zip tied onto here. We've already zip tied the unit here. Now in the unit you also get some thermal tape, so you put a piece of thermal tape onto here to ensure that this won't get too hot. We've done this quite a few times. We know that this installation, this location works perfectly for us. Now the red wire that comes out of the soft start module, this one here, runs through and it runs up to your starter solenoid. And you'll get a connector, a double pole connector, which you install and then put in the ignition switch wire. So what that does is it engages the soft start module when you turn your key to start. Now if you use a push button, it's just a different setup, and you'll read that in the manual that comes with the unit itself. But we use a start ignition. In order to do that, because this is only on temporarily and it retards the upper ignition, we actually need to start this engine without this ignition running. So we're essentially starting on this ignition alone, the top module, and we're only doing it for a very short burst. This is only in use for a very short burst. So we look inside the cabin, and we'll come into where our start switch is. And this is just a unit you can get at most places. We happen to use the Aircraft Spruce one. And we've wired this up so that you can see in here that we've wired it up where our green, our right, actually has the short on it. Okay, so we've installed the metal plate that comes with the switch. And I can't get the camera to focus there, so hopefully right there is good enough. You can see So we've installed the piece of metal there that shorts that when you turn on the start, and it disables this ignition unit. Easy install, and with the high compression of this motor and the starting vibration that does happen with this motor, if you don't have that unit, we find it a big benefit to have on. We also find it a little easier to start this motor in cold weather. With the installation of the Skyview, we are installing the EMS module and the backup battery up here in the front near the firewall. Now, we could have installed right onto the firewall, but we do have a throttle linkage right in behind it. So what we need to do is build a shelf. And the shelf has all the wires coming into it through the firewall, and it plugs in. We'll bolt this into the shelf, and that'll create a nice close run for our Skyview, and still allow our throttle nice free clearance. Now, once again, this is a particular installation for this aircraft, the Stoll CH750 from Zenith. Not necessarily what you'll need to do to yours. So we've got the cowling set, and we're going off the center here, and we're trying to move it back so we have a nice flow through the radiator and everything. And we've trimmed off the back to fit fairly close. Now, we've left ourselves a good amount of gap there, so we still have a little more trimming to do back there. But we've come into a point where we're up really close to the rad, and we maybe want to come just a little bit forward. But we're still, the prop flange is still in behind the cowling. So we've come to the conclusion that instead of trying to move this any further, repositioning the rad or doing any type of that work, we're going to add an extension on here. We're going to do a prop extension. And we've ordered up, we've called up Warp Drive, and we've ordered up an 1.5 inch prop extension, as well as a crush plate for the other side of our spinner. And we're going to install those and then put the prop on and get all the setting. This allows us to do a few things. It gives us a really nice clearance in here with the radiator. It recesses this, and our spinner will be a little bit closer, have a nicer look into here, and that was the best way to go through that route. So check what you have, and if you've ordered the prop with the kit, you've got the Warp Drive, you may wish to order up that extension. It's probably going to be your best route. Trying to move this any further, repositioning the rad and everything like that, is just going to be a little too much work. So once we get the prop extension on here, we'll trim the cowling at the back for the final a little bit, and we'll lock everything in and finish it off. Just passed, and this looks consistent all the way around. So I'm going to come in roughly about 40 millimeters. I want to see the rivet line from the firewall, because when we go to do our final cut on here, we're going to use that rivet line as our reference. And we're going to line the cowling up with that rivet line. And also in here and with this line here. Okay, so there's a few references we're going to take. And we're also going to measure down from here and from about, some predetermined point here down to the floor with a level floor to ensure that we also have the cowl squared off this way. But our first cut, we're going to come in 40 mils, just give us a rough idea of where we want to be. Our gear leg that's hitting into here, we're probably going to move back a bit. I mean, we're probably going to come back up into here. But we're just going to give it a quick little trim. Even with that first trim, that spinner is sitting 90 millimeters back. And we have to allow clearance for the back of the spinner. Sorry, I meant the prop flange is 90 millimeters back. We have to allow clearance for the spinner. And so we're about 110 millimeters we have to still move back. So if I come down here, and we're pretty happy with how level this is looking so far. We're pretty much on the center of the spinner, or on the prop flange again. So I'm going to come in here and just measure out the 110. For this installation, we have the warp drive propeller, and with the kit there's a 68-inch prop. We've actually opted for the 72-inch on this one. We still have lots of ground clearance with the 72-inch prop, and the owner feels that this is going to be a better choice for his particular application. One thing you need to do is you need to install the drive lugs in the prop flange. Many different methods of doing it. You know, we've heard of clamps. There are special tools out there. This is a fairly simple one. We're going to use a metric bolt with an Allen key and just a washer. And the socket we're using is a 1/4 inch drive, 9/16 shallow. We're just going to draw it through the hole.
Bottoms out, you added a couple of washers, you get extra length. This of course is bottoms on the socket.
Because these sockets have a shallow neck on them, we can't use the bolt to draw them all the way in. So we went with a deeper socket, a C-clamp, and it draws it in the rest of the way. So we've reinstalled the cowling, we've just set on, and we've marked back on the green tape, we've marked back from where the edge of the skin is, and we've come back 70 millimeters. So that'll be our reference line, and we're going to match the cowling up with the rivet line on the firewall, but we want to know where our edge is, so we've marked that. And we have the spinner on now. We've actually had to install a 1.5 inch prop extension, and we got that from Sabre, and it's also available from Warp Drive. So the 1.5 inch prop extension allows us to get the proper clearance to the spinner and not be rubbing onto the radiator. And as you see, there's duct tape from the spinner holding it onto the bottom of the cowling, and we've put a couple blocks of wood in there, just some small little scraps, you know, just to give us a pretty decent little spacing there. You can see them there, and we've got even spacing all the way down. We're just going to measure to the floor and make a reference as to ensure that the cowling is on there square. And then we're going to start popping clecos into it. Just bring this up a little bit. Get this snug, and you know, this way we see the line here matches up this way. And we'll put a cleco right there. This in nice and secure. This looks pretty. Now we're just going to double check all our lines. Once we're happy, then we can start locking some of this into place. Right to the. So we gotta figure out. We figure our even spacing here, 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 right around. So we have an even spacing through here. Our cowling is centered. Remember, we don't want to put a cleco in the center of this. So our first one's going to be out here and out there. We're going to work that way. Cleco into there. We'll go to the other side. Okay. Make sure nothing's moved while we're here. one there. Next one down. Be careful here because of the way the cowling is and the way the fuselage is. If you put too much force here, then you're actually going to bend in the cowl, the fuselage itself. So be cautious of that. You know, just put enough pressure on to bring the two pieces close together. Take this out very carefully. We painted our spinner when we had the slats done. And as we see, yeah, the cowling did come down a bit, but it came down to a perfect line. We couldn't ask for any better. And that's simply because we were using a little bit of force with these to hold it up. So we knew that there was going to be some sort of drop, a little bit, and we tried to accommodate for that when we put in all our clecos. So there it is, all clecoed up. Now we're going to just clean up some of the edges. This edge is a nice clean edge. We're going to do the same on this side as well, in between the two upper and lower cowling. And then we're going to straighten up our line back here, and we're going to install our deuce fasteners, or something similar to deuce fasteners. Okay, so we're happy with the position. Now we're going to take our cowling off. And we're going to leave our bottom on just to see if it holds well, holds true, and there's no sagging. This cowl is really quite strong. It's quite robust. So there, we've taken our cowl off. It looks pretty good. Nothing's moved here. We're happy with that. So we got a good amount of room here for the rads. You know, we're not squeezed anywhere. We got lots of room in the back. Come over, we can see all this here. Okay, gives you a good idea of how much the airflow is going to be underneath, and that's quite a bit. That's a good, decent opening, and the air will be pulled through on the two NACA ducts on the top. And also, we're going to install NACA duct on the side for our heat box, which is not installed just yet. We can have a quick look at that. Now, on this particular plane, and we'll get some of this wire out of the way, which isn't in yet. On this particular plane, we're not installing the standard Zenith Rotax heat muffler. The customer's opted for one that I use and I've designed for this type of install. Okay, and we're going to show you that. Now we'll explain the other one as well. The other one is a covering, which will slide over top of all this, and it's a good size covering. You know, it goes from over here to over here and envelops this whole area. And then it has a feed out. It picks up the air from the oil cooler underneath, and then flips out the air to the butterfly valve underneath on the Firewall. Now we have a little bit of a different heat exchange box as well. This one here does have a dumping valve. So, and that is actually necessary with the design I use. We do have to have a dump valve on it. Now the one with the Zenith one, which is it's worked quite well. That one there doesn't necessarily have to have a dump valve on it, because it allows you know, any trapped air, it allows it to escape around the muffler. So okay, so due to aesthetics, we've decided that we're not going to put the NACA duct on the sides. We are actually going to install it on the bottom. It's right in the air path. We're going to have a great amount of airflow in here. And it just makes more sense to do this. So we're going to cut this out, sand it into proper shape, install the plastic piece on the inside. We're still going to use flush rivets and we'll get them coated over and cleaned up. But this will work for now. In your kit, you receive for your cowling to mount the two together and mount it onto the fuselage. You receive deuce fasteners. Now, deuce fasteners are a spring connection, so we have spring in which we put two rivets through either end of the spring, and they're captured by a quarter turn deuce fastener. Good little units. If you know, they've been around for a lot of years. A lot of certified aircraft and home built experimental aircraft are using them. If you have the retainer that goes on here and it captures the deuce fastener and the cowling, that's really a nice benefit to have. We don't typically use these too often in the shop. We have, if it's up to the customer, if they wish to go that route. What we do use, and it's a very similar install, are called Southco fasteners. Now, Southco fasteners are very similar to the deuce fasteners. So instead of having the cutout in it, where you attach it right through a spring, this is Southco fastener, and I believe it's made by the same company that does the deuce. It's a little bit of a different shape. Okay, and what it does is it goes into this leaf spring. So we install these leaf springs within the cowling, and it provides a lot more strength, and also has a spring action in there. And they're a quarter turn fastener as well, so they just go in and quarter turn to lock. And they're operated with a quarter or a dime or whatever you have in your pocket. We typically use a coin because with a coin, when you're using a coin in your cowling, you'll typically have it captured in your hand like this. So you have your thumb and it's captured in there. So when you go take it on and off, if you slip, so if you're taking it off, if you slip, you're essentially not going to scratch your cowling. That's, you know, it's a small thing, but it does make a big difference. If you have a tight fastener and you're using your your fuel drain with has a screwdriver on the end of it, then you'll scratch your cowling. Happens a lot. So we just use these in the shop, once again by request. So we're going to install these ones. They're done very similarly. And what I'm going to do is I'm going to drill a hole first. I'm just going to use a step drill through this, just to get the center hole. I'm going to line it up so that it is straight with my bottom edge. And you can draw a line through there and reference it through the two holes if you're more comfortable with that. I'm just going to drop the hole in there. Alright, so here we are, and you can see through here, and we'll just double check the alignment on it. There. And it's lined up pretty good in through there. Alright. So what we need to do now is, once this is riveted in here, we're going to do flush blind rivets. We'll talk about that in a second. When we pull those two rivets, then all the strength is transferred from here to here. There really is no use for the fiberglass within this area at all. So we want to make sure that we remove a good portion of this so that it doesn't bind. So we just slide the fastener down. You can remove it if you wish. Okay, and the hole, we've gone up another size. Okay, that gives us a good amount of place. So we slide this back into place, and we see now that we've got a lot of room in there to get our Southco in and out. And it's not going to get caught up on the fiberglass. We could probably still go one size bigger, but that's likely not necessary. And if it is, then when we go to refit the cowl after it gets painted, we do need to open that up. Once again, not a big deal, very easy to do. So on this top cowling here, we want to install an oil cooler door. Now, originally, before these mounts were lengthened, the old original door used to be right here, and you'll see the possibly you'll see the patch. It's still an early cowl. Yours may be different a little bit. So we have the old opening here, which is filled in. So we need to move it, and we're going to be putting a hinge. Now, I've already trimmed this hinge a touch. I've just taken out a leaf on it already. And now we're going to go under, have a look at where our oil reservoir is. Now I probably said oil cooler earlier, but I meant reservoir. So we want to be able to get our hand in, reach in there and just check it. So we need to locate our hole such that we can do that. Alright, so we're just going to mark where the edge of our metal is here, just as a reference. We know that the old oil door here is right where we really, in the line this way, is where we want it. So we're going to just essentially move it back, and we essentially want our new one right in this area here, so we can reach our hand in and grab this. Now we're going to change this a little bit. We're going to put an external one on, and it's going to have a straight edge along here and come down like this. We mark this line here so that we have reference to our distance in order to put in a deuce fastener. Alright, so that's it. We'll haul this upper cowling off and we'll start getting into it. Alright, so here we have the once again the hardware kit that comes with your cowling and your Firewall forward. And we have the deuce fasteners, which we talked about earlier, and there's the springs for them. But also in this you have a wing deuce fastener. Okay, good close look at that. And this operates with the spring as well. This is what you install for your oil door, and we'll look to see if we're going to do that as well. Alright, so we've made our line where our skin is on the inside, and here's the old door that's no more in use because of the lengthening of the top cowling. So we've come into here. This is where we want our new hole, and it's going right into here. So we look at our door, and because there's curvature in here, we can't mount the hinge facing back. Because of the curvature, we have no way other than to build everything up, and we start getting just into too much custom work. So we're going to mount it this way, which is the way that the old door used to be mounted as well. And we're going to mount it like this. So this will be nice and pretty. And we'll put just a little bit of a round into this so that we get a nice fit on the cowl. So we chamfered the holes here. We flush riveted out here. And the painters will bring some putty over there so they'll be hidden. You won't even see those. But on the metal door, we're not going to go to the extent of dimpling and chamfering and all that. We're just going to come in with regular rivets, A4 rivets, and we're just going to use the concave nose piece as you have in the whole airplane. And our rivets there. So now it's all attached. You see how the door has a bit of a spring to it, and that's from these two ends here. So we have this nice and open. And when we close and latch, it'll be fine. We're going to put a washer underneath here just to draw it down a touch more, and also to protect the wear on the paint. So there'll be a washer underneath there, and that'll look very nice. Okay, so we've taken the cowling off, and now we've just evened it out on either side of the opening here where the exhaust pipe goes through. You've also noticed that we've changed our mind on where the NACA duct for the heating system is going to go. We've actually mounted it on the bottom of the fuselage. Now we flush riveted it, and these are going to be covered up with a little bit of putty from the paint shop, and that way we'll never see the rivets. We've mounted that down there simply because on the side of the fuselage, when we looked at the graphic design, we've got graphics going right on the side of the fuselage, side of the cowling here. So aesthetically, we didn't want the NACA duct in the side. So looking at it, it's in behind the oil cooler, and it'll pipe readily up to where the heat box is. So right now what we're doing is we're just going through it. There's a lot of flashing and everything that needs to be looked at. Clean off the edges, make the holes nice and round and smooth. Inside here, we'll have to clean off all these edges into here. Make them nice, check the corners. You know, a little bit of putty on them if you need to. Down in here, because this is actually an add-on insert for the oil cooler NACA duct, we want to clean this area up a little bit, especially like in through here. And we're going to clean this corner, make this a little rounder so we don't have any cracks happening down the road. And then we'll put some putty in and clean all that up. And once it's painted, we won't even see any transition there. We're pretty good with the NACA duct down here. These ones over here on the top of the cowl, once again, we're going to clean up here. We're just going to relieve these corners just a touch because you'll end up with cracks promoting if you don't put in a little bit of a round here and here. And we're going to check inside, and we get a rough spot in here, we'll have to clean up as well. Same thing over here. As you can see right here, we've got a little edge here that's out of shape here. So clean this up, clean this up. This area here, we need to clean this out a little bit better. It's just, we're not happy with the way that looks. So just things like that, go through it, have a look. Check it over really well. We see on the cowling, here's the inside look of the installed South Cowl fasteners. There we go. There we go. Hello, I'm Mark Townsend from Can-zac Aviation, and today we're in our shop and we're just going to have a quick look around. There's been some inquiries on the builder assistance program we offer for the 750, and we're just going to have a quick discussion about that. Our builder assistance program is very simple. The owner of the plane comes in, and as you can see, we're standing right here in front of a box that does have a 750 into it. So this is another 750 that we're going to be starting in another couple of weeks. And we have a schedule all laid out here that shows the work and the flow of the project from beginning to start to finish in the 2 weeks for the builder assist. And we have something similar online as well. And it shows everything. Now in Canada we do have inspections. I do have US customers that come up and do this as well. And this shows that what the customer is responsible for during the time here and what we are responsible for. And within the 2 week period, we'll essentially have the kit out of the box, inventoried. The wings will be built, the tail section will be built, and the fuselage will be built on its wheels. We should also have the motor installed on there, and in Canada at that point in time we'd have an inspection. After that, then it's a matter of some finalized work. And if the builder wishes to continue on, then by all rights they're allowed to. There's no problem with that. Or if they want at that point in time to just put it in the trailer, take it home, do the wiring, the final installation and all that, more than happy to have that happen as well. If we look over here, here's a plane that we're doing now. This is week 3. So we're into our 3rd week here. Far more than just having the airframe done. This plane will be going to paint in a day or so. And all the inside's done, all the controls are in, all the plumbing for the wires already run, the pitot static system's already installed, the panel's been cut out and installed in here. We're just leaving because we're going to paint the interior shortly. And then when it comes back from the paint shop, we'll get the panel installed and all finished. We have the Jabru motor on this one. So in this, the cowling's already fitted. And we've done a couple little changes that the customer desired. And that's fine, that happens as well. But this is all done, wired up, ready to go. Just the ignition wires for the starter and that, and we're all finished there. If we look, I also do repairs. We have a plane in here right now that's on floats. It had a bit of a rogue wave incident, so we have a little repair going on at the same time. That one will be done today. And then here we'll see the wings that are over here. So the wings are already built already. We should be installing these probably on just before we send it off to paint. We'll set the dehedral, the sweep back and everything. Fuel system is installed, the electric's installed, the wingtip, the lights will be on, and it's all ready for mounting right on the plane. So this is essentially, mostly completed within a 2-week period. It is a very hard-working 2 weeks. I realize that our customers come up here for a period of time, and typically they're in a hotel or motel for that time. So we work long hours. Typically a 12-hour day is not uncommon. It's more the norm. Longer hours do happen, and it's 7 days a week throughout the whole build. So at the end of it, we have your plane together as fast as possible. And yes, we do coat all areas, mating surfaces with zinc chromate. Now, Angus, I don't know, would you like to have a word?
Sure. Well, the build assist is ideal for builders that are contemplating building their first airplane. Because it's a bit of a daunting task to contemplate that without 2 key ingredients. One is the tools, which most people don't have readily available, and the second is the expertise. And when you put those together with this facility and Mark's presence, that is the recipe for long-term success, for building it on an accelerated timetable, but also building it right.
So in here, we don't have a bunch of staff. It's essentially myself. I do have a couple others that help out part-time, but it's myself and the builder. It's a one-on-one situation. I'm working hand-in-hand with the builder, the owner, and to get the project done. Thank you.